Hello student, this is Kritik Rajgor and today we will discuss few numerical from the gate mechanical. So let's start very first with this FM numerical. What is given in this question? If we read this question, we will understood there is a one steel rod whose length is 15 centimeter. How much will be the length of the steel rod? It is a 15 centimeter steel rod whose relative density is 7.4, and this cylinder, or let's say the steel rod, is submerged in a two fluid. One is a mercury and one is a water, and we need to calculate the height of top surface of rod above the liquid interface in centimeter. So let me draw this numerical in the pictorial form so we will able to understand very quickly. So what is given in this question? There is a mercury which is in the bottom and there is a water. This is what the mercury, and hope you remember for the mercury the specific gravity is 13.6. We denote specific gravity with letter S, and Hg means mercury. Okay. There is one more name for the specific gravity which is relative density. Okay. The bottom is mercury and top is water. There are two fluids, one is a mercury and one is a water. In the bottom there is a mercury and at the top there is a water. So water has a specific gravity which is equal to 1. This is not given in a question, but you must know this value. Yeah, because it's very basic and can be easily remembered. So what is given? There is one steel rod. Let me draw the rod in this fluid. This is what the steel rod. The height of the steel rod is 15 centimeter. How much will be the height of this rod? It is a 15 centimeter. This height is 15 centimeter. 15 centimeter. So what we need to calculate, read this last statement, the height of top surface of the rod above the liquid interface. So let me mark this is as the top surface of the cylinder, and we have to calculate this height from the liquid interface. Liquid interface means where two liquids separate. Okay, we need to calculate this height and we mark this height as a h2. Okay, and this height, this bottom wala height, we mark this height as a h1. So h1 is a height of cylinder which is inside mercury. h1 is a height of cylinder which is inside mercury. Okay, and h2 is a height of cylinder above the liquid interface, and we can also say h2 is a height of cylinder which is inside the water. So let me solve this question. What is given in this question? First of all, they given a specific gravity, or we can say the relative density for the steel, which is 7.4. Relative density for the steel is 7.4. We can either name it as a relative density or the specific gravity. It is one of the same thing. And they also given a height of the cylinder. We mark height as a letter H and we keep it in a centimeter, which is 15 centimeter. Now what we need to calculate, we need to calculate the height of top surface of a rod above the liquid interface. Means we need to calculate this H2. What we need to calculate? We need to calculate H2. Yeah. So we use the Archimedes principle. What is Archimedes principle? Weight of fluid displaced, weight of fluid displaced placed is equal to the weight of body. Whatever will be the weight of the cylinder is equal to the weight of the fluid displaced. Now how to calculate the weight? We calculate weight from this formula rho gv. Do remember how to calculate the weight? Density multiplied by gravity multiplied by volume. So this is what the formula to calculate the weight. So we will calculate the weight of a fluid displaced. There are two fluids, one is a water and one is a mercury. So we need to calculate the weight of the mercury which is displaced by this cylinder and the weight of the water which is displaced by the cylinder. So let me mark or write something like this: rho GV, V means volume, and we mark this as a Hg, means the weight of a cylinder, or we can say the weight of a mercury displaced by the cylinder plus weight of a water displaced by the cylinder. मतलब सिलेंडर ने कितना वाटर डिस्प्लेस किया उसका वेट, एंड हाउ मच mercury has displaced by the cylinder, that weight, which is equal to the weight of this body. How to calculate the weight of this body? Rho GV, and this body is made up of steel, so we will write St as a steel, Hg for the mercury, H2O for the water, and St for the steel. Now do remember how to get the density. Density is nothing but the specific gravity multiplied by 1000. What is 1000? It's a density of water. Okay. So we use this formula of density and substitute something like this. Instead of this first bracket, we will write S of Hg multiplied by 1000. This is what the density for the mercury. Density for the mercury, and this Gg will get cancelled because it's common. So rho Hg multiplied by volume of Hg. What is the volume of Hg? If you remember, the volume will be pi by 4 d square multiplied by Hg. What is the height? H1 plus same S of H2O multiplied by 1000, means this is what the density of water multiplied by volume displaced by the cylinder. कौन सा volume? Volume of water displaced by the cylinder. So pi by 4 d square, and height of cylinder inside the water is H2, which is equal to the S of steel multiplied by 1000. This will become density, and what will be the volume of steel, or what will be the volume of the steel rod, is pi by 4 d square multiplied by height, total height, that is H. Okay, so what we will do, this 1000 will get cancelled, even this pi by 4 d square will be get cancelled. So we will end up with very simple formula, that is S of Hg multiplied by height H1, height of Hg inside the cylinder, and SH2 multiplied by height of cylinder inside the water, which is H2. This must be the plus, it not be the minus. Here it must be the plus. Now which is equal to S of St multiplied by height. Now what we will do, we will substitute the value of 1 by 1. What is specific gravity of mercury? It is 13.6. Okay. This height H1, what we will do, we need to calculate H2, so we will replace this H1 in terms of H2. How we can replace this? If you remember, what is the total height of cylinder? It's 15 centimeter. Can we write something like this? H1 plus H2 is equal to the 15 centimeter, or H1 will become 15 minus H2. So this H1 will become 15 minus H2 plus specific gravity of water is 1 multiply by H2. Specific gravity of steel is given, which is 7.4, and the total height of cylinder is 15. So only unknown in this equation is H2, and when we solve, we will get H2 as a 7.38 centimeter. H2 is how much? 7.38 centimeter. This is what the final answer to this question. H2, we need to calculate the height of cylinder above the interface, that is H2, which is 7.8 centimeter. And if you go to this option, the option D will be the correct answer. This option D will be the correct answer, which is 7.38 centimeter. So we will move to the next question, which is this. What is asked in this question? This question is from the heat transfer, and what they have asked, let me read this question so we will understand it one by one. For a current carrying wire, a 20 diameter having conductivity 0.5 and exposed to the air whose heat transfer coefficient, that is H, is given, which is 20, maximum heat dissipation occur when the thickness of insulation is, means we have to calculate the thickness of insulation. So let me explain this question to you. There is one wire whose diameter is 20 mm. The diameter of this wire is how much? This is 20 mm. And they have given the conductivity of this wire, which is 0.5. Do remember the unit of conductivity is watt per meter Kelvin, and the heat transfer coefficient they have given as a 20, and it's watt per meter square Kelvin. Okay, now if we know the dia is given, dia is how much? It is 20 mm. What will be the radius? Obviously half the dia, which is 10 mm. This will become, radius will become 10 mm. Let me write the radius somewhere over here. Radius is what? D by 2 means it's 10 mm. Okay. So what they have asked us, they have asked for the thickness of insulation. This is what the wire, black color में जो draw किया है, this is wire. Let me draw the insulation with the red color. This is what the insulation added over the wire. You see that rubber coating on the wire? This is basically the insulation. The actual wire is inside that copper wire we see in day-to-day life. And this is what the insulation. So what they have asked, they are interested to calculate, or they have tell us to calculate this thickness. The thickness हमें calculate करना है. This is what the thickness of insulation. Let me draw this axis, and this is what the radius R. This is the radius of the wire, which is R, and this radius of the insulation, we name this radius as a RC. Why RC? Because it's a critical radius. Now, what is critical radius of insulation? Here, before getting into this critical radius, let me tell you how to calculate this thickness. It is very simple. What is thickness? It's RC minus R. RC minus R. So, we need to calculate this thickness. Now, it is a which thickness of insulation when the heat dissipation is maximum. कौन सा thickness calculate करना है जब heat dissipation maximum हो. When the heat dissipation will be the maximum. There is one graph. Let me explain that graph over here. In this graph, on the y-axis there is a heat transfer, which is we denote with letter Q, and on the x-axis there is a radius we represent with letter R. So in this graph there is one curve something like this. It means at this position Q will be maximum. So for this maximum Q, what will be the radius of insulation? We name this radius as a critical radius of insulation. And for the cylinder, its value is K by H. Wire is what? Wire is one type of cylinder only. Okay. So why we are dealing with this RC, which is K by H? Because they have asked for the maximum heat transfer. So maximum heat transfer कब होगा? When the critical radius of insulation is K by H. Okay. So how to calculate this value? Now the question will become very simple once you understand it. So let me solve over here. How to calculate this RC? RC is K by H. Just substitute the value. We know K is how much? 0.5. K is 0.5. And how much is the H? H is 20. So when you do this calculation, 0.5 divided by 20, it will turn around 0.025, and it is in meter. So when we convert this meter into the mm, we have to multiply it with 1000, so it will turn around 25 mm. Okay. So don't mark this 25 as your answer. They are not interested in the critical radius. They are interested in the thickness of insulation. So what is thickness of insulation? Do focus over here. T is what? RC minus R. So what we will do, we will calculate simply the thickness. Thickness of insulation is RC minus R. So We will substitute the value of RC, which is 25, and value of R, which is 10. So the thickness of insulation is 25 minus 10. Very simple. It's a 15 mm. This is what the answer to our question. This is what the final answer. Thickness of insulation. So option D will be the correct for this question. Option D will be the correct answer for this question. So I am hoping that you understood this two question very well. See you in the next video.